So going back to regression and especially talking about the context that we just discussed from a decision tree point of view, that you have to continuously wear your business hat, and the the team assignment that you submitted on the uh, median starting salaries of students graduating from a university, right? So, and I mentioned that to at least one team, um, and some of the other teams just conducted a correlation analysis without actually talking about it. So that really doesn't tell me anything. Um, you have to invest into the work and make a case for why actually you're doing a correlation. Um, just because Dr. B asked you, you don't do it. Okay, so when you do the correlation, make sure that you explain a little bit about the dynamics of it. Um, there are at least three teams who did that, and I think a couple of teams didn't even bother talking about why the correlation was done. It was as if a check off box more than anything else. So hopefully that will be better going forward. Um, one thing about the correlation that I want to discuss is when you run the correlation, especially for the data set that you just submitted as part of case one, um, you will see that your SAT and ACT scores are highly correlated, which is kind of a norm, right? So they are asking very similar questions. So students would typically do good on SAT, also do good on ACT, and so your scores are expected to be highly correlated. Um, on that same note, when you are going to a private school versus a public school, private schools typically have a much steeper tuition fees, and therefore the annual cost, there is a stark difference between private schools versus private public schools, right? So typically, if you look at it by private versus public schools, you will see that it is highly correlated. Um, so when you run that correlation matrix, if you just go by numbers, there is a natural propensity to try and take a decision that, oh, well, we'll take one of these out, as Dr. B mentioned. And again, at this point of time, you're thinking as a mathematician, right? So it's just numbers game. Um, and then which one do I take out? I just look at the Y variable and I see which one has a more impact in terms of correlation with the Y variable. If it is significantly higher, I take the other one out. Mathematically, it's spot on, it's perfect. The problem with that is this is where we differ as business students. We want to take a step back and ask ourselves, uh, given the context of this problem, should these variables stay in the model, right? So SAT score is typical focal point of admission decisions across the country and oftentimes in many other parts of the world. So irrespective of whether there is um, a high correlation or not, you would not want to take SAT out of your regression model. Let the model run the regression. Based off of that, if it eventually throws it out, it's a different scenario. But as part of your correlation coefficient, it is not a good idea to take out SAT scores, because this is where you look at a reality rational driven check. Um, on that same ground, when you talk about uh, median salaries of students graduating from private universities, which turn out to be a little bit higher oftentimes. That is not necessarily because they pay a hefty fee for that. That fee also goes into a more personalized career map, a curriculum map for students. There are so many different clubs in which um, the student is invested in. The university, because of its uh, channel of funding, has a lot more funds invested into career counseling, into employer relations, and so on and so forth. And all of that collectively attribute to a higher median salary oftentimes. And of course, if it's an older private school that has a brand of its own, then that brand goes a long way to provide for that higher median salary. So there can be so many other things at stake beyond just the cost, which is why, um, and this is the same story you should apply at each and every step. of your analysis. The correlation gives you a smell test that one of them will be kicked away. But unless you're absolutely sure that the specific variable is really being a nuisance as opposed to can have an impact on the overall Y, you would want to keep it. And if you keep it, then you have to make a case. You just don't say it to your head and then just provide me a correlation matrix and say nothing under it, because that defeats the purpose. You have to explain, what you did with the matrix and why you are leaving it the way it is. Okay, so that's very important. So what I'll do is, um, I'm I have a data set, and I'm going to stop the share here. I have a data set under your data sets tab in Blackboard. Okay, and let me see if I can share my. Okay, so can everybody see my screen? Yes, no? Okay, so if you look under the data sets used in class tab, and if you scroll down into week 13, 14, we are on week 14, PowerPoint data sets. If you click on that, you will see a file called dataset regression 1. Okay, I want each one of you to open that file. Okay, there's a file called dataset regression 1. Okay, I want each one of you to open that file. So we'll follow the same format that I have followed in the past. I have this box full of numbers, and I'll just pick one number, and whichever team is picked will present. We'll see how it goes. We may actually end with only one team, because the expectation is that all teams are thinking similarly in the same data set, and the critiques that I shall offer applies to every team. And so, of course, this session has been recorded, but you can also the teams that are not presenting should take notes and make sure that you are up to speed with what has been asked. So the expectation is simple. When I ask your team to present, you quickly get to the regression piece of the puzzle and explain in detail every step of the process within regression. Okay, I want to have a clear understanding of what R square means. What are you getting out of ANOVA? What language are you using? Looking into the regression coefficients. What is your logical approach? And I may want to stop you at times if I have to correct you. Okay, so this is by no means a presentation that I am critiquing. It's the content that I'm critiquing. And so if you are saying something that is not correct, then I shall stop you and I shall correct you. Okay, so with that, let me just pick one of these. Let me see which one is this. So this is team 5. Team 5 is Nick, Ashley, Nathan, and Steve. So uh, whoever wants to go.
Okay, I'm going to share my screen really quickly.
Okay.
So we were looking at the data set and realized that a majority of these are um, relative or relative to stock price. And so each of these variables um, impacts the stock price. And so stock price would be our Y. Um, and so when we ran the regression, obviously stock price was our Y and the rest of them were our X variables. And so this was our output for our regression. R squared of 56%, that's just the explainability of these variables and their impact on stock price. And so when we go into our ANOVA output, we look at our significant.
Stop for a second again. And this is not a question for Nick per se, it's a question for the class. When Nick says 56% explainability of what?
Of what's impacting the stock price.
So it's the explainability in the variation in Y.
Yes.
That is been explained by all of the X's taken together. Okay, so earnings per share, ROE, current assets, current ratio, all of that taken together explains 56% of the variation in Y. That is what R square is measuring. And so is that stand alone, if you didn't know what is below it in terms of ANOVA and stuff, is that a good number?
Not really, no.
Not really. So um, real quick, what could have attributed to a better R square number without looking at the ANOVA and the other outputs, just looking at your data set, what could have made that R square number a little better?
Is this for me or everybody?
It's for everybody.
Okay.
Maybe more variables.
More variables is one way of looking into it. In other words, you want to say, all you are saying is ROE, earnings per share, current assets, and current ratio together explain 56%, which basically means the remaining 44% that is not explained is coming from factors that have not been considered in this model. Does that make sense to everybody?
Mhm.
Okay, so more variables. What else?
Would a larger sample size help?
Well said, Amy. Yes. So this is a sample of what, 38 observations, maybe, or something like that. Um, 35. So, um, uh, so can I request remote control?
Sure.
I promise I won't get into your bank accounts, Nick.
No, you're fine.
Okay, so forget that you have access to this data. If I tell you just by um, uh, clicking on this part and I ask you what is the sample size, how would you say it's 35?
Because our degrees of freedom is 34.
Total degrees of freedom are 34, and therefore you can say just by that number that there are 35 data points. By the central limit theorem, it's probably good enough to assume normal distribution and run all 9 yards, but you can clearly say that it's too small a data set. Okay, so those are some of the issues that are plaguing that small number of 56 out there. Okay, that those are some of the underlying reasons for which that explainability is not as high. Does that completely make that model inadequate to do analysis? And that's where the ANOVA comes into play. And when you look at the ANOVA, you look at that significance value, which is quite low, which basically tells you what?
The variance, the variability.
Yeah, so when you are running an ANOVA from a regression analysis standpoint, what is the hypothesis for this ANOVA test? If you reject the null hypothesis, what do you say?
The stock price has been is impacted.
So in other words, from a modeling perspective, because you are going to look into the regression model, your ANOVA hypothesis is basically saying whether the model exists versus it doesn't. Is it a good model to work with versus it is not a good model to work with?
Mm-hmm.
Okay, so um, that is where the rejection helps you. To be able to reject the null hypothesis, you're essentially saying it's a good enough model to work with. If that number was very high, then you would have stopped right there and said, I don't have any reason to look into the last part of this outcome.
Right.
Okay. Finally, this is where you have to be very, very careful in terms of um, let me check something real quick. Okay. So this one, what I essentially did was looked at the p-value part, and I'm going to stay with what I have taught you. Um, it's a probability, so it's 4 decimal places to the right, and by default, it's um, having a general format, which is where you see the e raised to negative and all of that. You convert that into number, and it's much more easier for you to make sense of it. Okay, so I want to hear from the team um, for two outcomes that are quite dissimilar. What made you put the same um, highlighted color on those?
So do you want me to go, Dr. B, or do you want someone else on the team to go?
No, this is your team. So
Okay.
whoever in your team wants to go.
So we looked at the different X variables, and earnings and share is below the p-value, and so when you look at the description of them, um, our other one would be current ratio, which is current assets versus current liabilities. And so if we're looking at risk versus loss, although the current ratio is greater than 0.05, we thought that it was still significant from a business sense, because it would make sense that if your current assets and current liabilities ratio is off, depending on how risk averse you are, you would use that as a variable or not. And so we.
So how much risk are you willing to take in your judgment? Clearly, it's not 5%.
Right.
So you're willing to take 20%?
Yeah.
So that is your definition of risk averse. That's how you're going to go about it, right?
Mm-hmm.
Okay. And again, I have no problem with that as long as you very clearly articulate those thoughts and explain why you have. There are so many students, and again, I see a big change in difference of quality between assignment 6A, 6B, and the case, but it's very hard for me to make an objective evaluation because the case is a teamwork. So I don't know how much of that is attributed to that specific student. But in 6A and 6B, for so many students, it was a straightforward picking all of the p-values and putting it a color code. That doesn't tell us anything. Okay, you are putting a 0.58 p-value and a 0.02 p-value with the same color code. What does it mean? Okay, and then I see so many people color coding the coefficients. Don't go that route, please. So the idea here is very simple. Again, one more time, there are 3 parts to this outcome. The first part tells you the overall explainability of the model. The second part tells that same story using ANOVA that tells you the level of significance, which tells you whether the model exists or not. So for most continuous data with typical linear regression that you have learned in this class, you would see in the first 2 stories to go the same direction. Okay, if you have a healthy enough R-square value, you should have a good, a low, very low significance value, F, p-value, that will ensure that you can work with the model. The model is workable. And then working with the model, the first thing you look at is not that coefficient. The first thing you look at is which one of these factors should stay in your final model. And that is what the p-value will tell you. The p-value is always the first thing you look at after you have moved on from part A and part B into part C. This is where you start looking into the p-values, compare that against an alpha of your choice. And if you are changing the alpha value from 0.05, just the way Nick did, you have to make a very clear rationale as to why you are increasing your risk averseness here. Okay, what is the context? What is the backdrop? And so based off of that, then you highlight, and you could actually make these green too. That tells you that you give the green signal for those variables to stay in the model.
Sure.
Okay. So, and once you have made that distinction, now it is time for you to write the overall equation. So your Y, which is year-end stock price, equals 26.0429, which is your intercept coefficient, plus 3.168 times earnings per share, minus 1.278 times the current ratio, because this group decided to keep current ratio as one of those variables. You do not use an error term here. The error term is designed for a generic equation. When you have not run the regression, when you are designing the conceptual model, that's when you are saying, even before you have gathered your data, that, okay, I'm going to look into understanding year-end stock price as a function of ROE, earnings per share, current assets, current ratio. Okay. So whatever else that I am not considering, that is my error. But the moment you are looking into um, something like an output of a regression that is very specific to this data, the moment you are looking into the, I can't write on your screen, so uh, the Y hat, okay, so the expected values, okay, and the expected value of the coefficients, which is what the second equation is, that's coming specific to the data set. Under those circumstances, there is no more error term. It is only specific to the data. So, and the final part of this puzzle is being able to interpret what that equation means. Interpret what the equation means. So what is the relationship between earnings per share and year-end stock price? Let me ask somebody that is not part of this team. Timothy.
I think he was having some connection
Oh, I
issue.
think that's he was the one who actually got off.
But I was in his group. I can answer.
Go ahead, Amy.
We said that for every increase of $3.16 in earnings per share, that stock price increases by $1.
Oh, whoa, 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 hold on. Okay. That is not right. Hold on to that thought. I am going to stop your share, and I'm going to share a basic whiteboard here. If I am asking you what is the relationship between Y and X, Amy, what you just said, you said for every 3 units of increase in Y, X increases by 1 unit. It's the other way around, right?
Yeah, I was thinking the other way around.
Yes. I think probably you misquoted the variables. So for every unit increase in X, your Y increases by 3 units, right? So if your X is 1,
So for every increase,
so if your X is 1, Y is 3. If your X is 2, Y is 6, right? If your X is 3, Y is 9. In other words, for every unit increase in X, Y increases by 3 units, right?
yes.
Right. So on that same note, go back to your screen again. Nick, please. Let's try this one more time for earnings per share. Amy.
Yes.
let's talk about this relationship between earnings per share and year-end stock price.
So it would be price equals 3.16 times earnings per share.
Which basically means that for every dollar increase in
Earnings per share
your year-end stock price increases by
by $3.16.
$3.16. That is the interpretation in this context. Real quick, go to the description for me, Nick. The description said, okay, so current ratio is a widely used performance metric, especially that allows you to see the burden that every company is carrying. So current assets over liabilities, right? If it is assets over liabilities, you want the current ratio to be high or low? That's my first question.
Hi.
Does everybody get that? This is not a finance question. It's a basic common sense question, right? Okay, liability. You don't want your liability to be high, right? You want your assets to be high. So you want your current ratio to be high. Sometimes too high current ratio can be a problem because that's too much of liquidity and holding. But normally you would want that number to be high. So let's go back to the data, the data tab. So now, this part is interesting. Who is an ex-finance major from here? Raise your hand. Okay, Brandon. Let's see how we explain this relationship.
So for every increase in current ratio, you'd see a decrease in stock price of $1.28.
So current ratio is a ratio, right? It does not have a specific value or measure, right? Like dollars and cents, right? So
Right.
current ratio is just a unit. So for every unit increase in current ratio, your stock price reduces by $1.27, right?
Right.
So if your current ratio goes from, let's say, 2 to 3, how can we put that in the context of assets and liabilities?
So it would be doubling, right? Your assets
So
versus
your assets go from twice the liabilities to 3 times the liabilities, right?
right.
So you are building on your assets. So sometimes building purely on assets because you're holding too much assets at hand, and given the disruptive nature of businesses today, especially the high uncertainty of doing business, holding too much assets may not be the best option, which is why the stock prices kind of trigger. And that is just one way of trying to explain that relationship. And that is just Dr. B's approach. If you have a different one, you guys are finance majors, you know much more than I do. So any other thoughts? Sarah Al-Zarani, weren't you a finance major?
Financial planning more than analytics, but
So
sure.
there you go, planning. There's no escape here. This is all planning. So what are your thoughts?
I think it's very tricky to measure stock influence based on these sets of ratios specifically. Like Justia mentioned earlier, I think in our group we studied all the finance ratios on Yahoo Finance, and there's so much to look at.
Yeah, so that part has already been taken care of in the context of your R-square. That's where you have an R-square value that's not too high, because there can be many other ratios that would probably bring about an adequate relationship. And oh, by the way, understand that you may not even want to put current ratio as a plausible variable in your model. It was this specific team that decided to keep current ratio as a variable in their model because of how they looked into the idea of risk versus loss. If you look by a more traditional approach, that 17% is a very high number. Okay. That 0.1730 of a p-value is a very, very high number. So it depends on how risk averse you are in terms of trying to keep current ratio in your model or not. Who did I lose in this last 1 minute of conversation? Raise your hand, let's be honest. Oh, good. Because if you don't raise your hand, I'll know that there is no correlation between what we are doing right now and what I saw in your assignment 6B. So here is the basic piece of the puzzle. When you move from the first part, which is the explainability, to the second part, which is ANOVA, that kind of tells you a similar story, and it tells you that the model exists. The final part of the puzzle in the third piece is essentially trying to figure out which of these variables will stay in the model. And it's the p-value that will tell you whether a variable should stay in the final model or not. Most of the other teams probably have taken current ratio out of the final model and have defined that model just in the context of the intercept and the earnings per share. And it all depends on how you want to interpret that p-value. The p-value approach that we have learned in this class is very much a comparison against what? Isabel, what do you compare p-value against?
Oh Lord, what do you compare p-value against? Okay.
This is something we have been doing since our z-tests.
I know, I'm so bad.
P-value against
Is
alpha.
it
Against alpha, right? Your alpha is 0.05. That's what you're comparing against. And you're trying to see if your p-value is less than or more than alpha. If it's less than alpha, that's when you reject the null hypothesis. And in these cases, every time you're able to reject the null hypothesis, you are saying that these corresponding variables, they stay in the model. If you cannot reject the null hypothesis, then they can't stay in the model. So if you are going by a p-value of an alpha of 0.05, the only one that you can really keep in the model is earnings per share. And the buck stops there.
I have a question. Is now a good time?
Yeah, go ahead.
Okay, so this is, I mean, it is related to this, but I'm going to throw it back to assignment. I think it was 6B, and we were doing it with the countries.
Yep.
So you said that the all that data on the countries had a natural high correlation. Yes.
Yes.
And so we shouldn't be, but that was okay. So there was the correlation tab that we made, and all of those correlations were really high. And you said not to worry about that. I guess I got confused because I know I got this part wrong on that assignment. I guess I thought that meant that we were to also ignore the p-value.
Ah.
Really very wrong. Yes.
Yeah.
Okay.
Yeah. Yeah, here that correlation part, thanks for bringing it up, Sarah. Now it makes more sense for me when I think about the color coding you did. I thought you had a color coding in your correlation as well. And so now I'm connecting the dots. Okay. So here's the deal. The correlation gives you a smell test. And in certain cases, if there is very high internal influence, that can allow you to take one or two variables off before you run the regression. Once you move on from correlation, the regression is its own animal.
So there's two phases of potential removal of variables.
Absolutely. Absolutely.
Okay.
In fact, in many other textbooks, they'll teach you that you can run the regression multiple times. I am not a big fan of that process because every time you use of the data, you lose what we call degrees of freedom. And so it loses the power in the test. And that's why I want to keep it only a one-time regression run. But there are colleagues of mine who will teach multiple regression, stepwise regression as it is called in textbooks, where you run the initial set of regression and then run the regression again with only those variables that fit in the model. But every time you do that, you're using up the data multiple times. And so that is losing the power in your instrument. Right? So, but long story short, going back to Sarah's question, it is a very valid question, and I think some of the other students in the class may have had a similar difficulty. That correlation gives you a smell test, and specifically in the context of economic data, all you had to do was just write a short note there saying that because economic indicators are very highly correlated to each other, we are foregoing the outcome of this correlation and moving straight into the regression by keeping all the variables in the regression model. And then when I say by keeping all the variables, what I meant was you run the regression with all the variables. And then based off of the outcome, then you make the decision as to which ones finally stay in the model and which ones don't.
That makes sense now.
There you go. As long as it happens somewhere throughout this semester, I'm happy. We still have a lot more to go. So you'll be able to apply that multiple times.
So Dr. B.
Yep.
What would be, if you're going to, if more than likely the regression is going to kick out which ones that aren't needed for your equation, do you even have to do a correlation?
Good question. The correlation gets you a feel of the data more than anything else, which is why I always say that anytime, and I have to find a good example for you in which you can right away say, okay, this data point, this data variable has to definitely go. But to be on the safe side, Ashley is very right. The regression will kick it out eventually as it looks into the cumulative impact of all the factors taken together. And that is the reason why when you run the correlation matrix, you should always give it a second thought, even if the internal correlations between certain factors can be very high. That's where the business aspect comes into place. It's more of an understanding process than actually taking a decision from there. You're very right, Ashley. So all of this discussion that we were having here, this all stays within the regression tab. If you have to put this concept back into a summary tab as a key recommendation or a key insight, or both, how would you go about it?
You would just stick to explaining basically the equation in sentence form, where you're saying
the equation in a sentence form will be explained right here in this tab. And I've seen many of you do that in the summary. The summary is much more simpler. Okay, the summary will basically say that current assets is the biggest mover and shaker of year-end stock price. Sorry, not current assets. Earnings per share is the biggest mover and shaker of a year-end stock price. And you can simplify that by saying with every dollar of earnings per share, your stock prices can increase by more than $3. Exactly that language, more than $3, not 3.16. Okay, layman's term, simple, straightforward.
I have a question.
Yes.
summary. So let's say we had 3 or 4 variables here that had a p-value that we could use. So in the summary tab, would you only say which one had the most impact?
I think that is where the idea of a key comes in, right? So all of these are impactful, but something that really is a takeaway, something that is the most impactful would be the key outcome.
Okay, so
And
maybe
then,
kind of,
and then building on that outcome, then you would provide a recommendation that is going forward. What is a decision that you would want to make based off of that outcome?
okay.
Does that make sense? Okay.